This goes to the starter solenoid on the side of the starter motor. It's the only wire that comes from the ignition and goes to the starter motor. It was obviously put in when the previous starter solenoid was bypassed. One problem I was trying to trace was that the car would start, whether it was in drive, neutral, any of the settings on the gear stick. So I checked underneath the wiring to the gearbox. That all seemed fine. There's a black and white wire, this one here, that forms an earth, and that operates in park and neutral. And so if that's not operating, that black and white wire is not providing an earth, then the starter relay will not kick in and it will not start the car. The yellow and white wire here is the wire that goes to the ignition switch, which should be connected between there and there as well. So this wire here should be connected to that one there. This yellow and white wire is the power coming in from the ignition switch, which should then go out this thicker wire to the starter solenoid, but also it's the power for the positive side of the switching mechanism, which operates together with the black and white wire there. So interestingly, when you open the loom up a little bit, I found this red and white wire totally disconnected. But this one here would have provided the power to kick in the starter solenoid. This is what the starter relay actually looks like. W2 should have the black and white. C1, this one here, that has the white and red wire. The feed from the ignition switch should go to C2, and then that's the white and yellow wire, and then there should be a jumper going to W1 to power the switching side. So when you're in park, you've got an earth to this W2 here, and when you turn the ignition switch to start against a spring action, that will power these two. The power going to W1 will allow the switch, and then that will transmit the power from C2 to C1 and thence to the starter solenoid. I do not have a functioning starter relay on my car because it's been bypassed. So what's happening on this relay, this bit here, is the W's are the switching mechanism. This white and yellow wire is bringing power directly from the ignition switch. No fuse, directly from the ignition switch to C2, and then to operate the switch there's just a jumper to W1. W2 is the earth, and that earth, that black and white wire, that actually comes from the gear inhibitor switch, which is here. That doesn't actually work on my car. Well, the switch doesn't, or there's a problem with the wire. So when in park or neutral, that will be earthed. When it's in any other gear, it won't be earthed. When it's earthed to that point there, and when you turn the ignition over to the start, past the spring pressure, power comes in, operates that electromagnetic switch that's in there, and then the power goes from there to C1, out of C1 on the white and red wire to the starter solenoid. That's how it functions on the circuit diagram. So one of the reasons for bypassing that starter relay, no doubt, is because neither in neutral or park are we getting an earth. Although the inhibitor switch is turning on the reversing light, which is one of its functions when you put it in reverse, that inhibitor switch is not providing a earth to operate the starter relay. I've attached a new mini relay in place of the Lucas relay. The white and yellow wire goes to 30, and that is from the ignition switch. There's a jumper that then leads round to 86. 85 has the earth. This black and white wire that goes to the gear inhibitor switch on the gearbox. This black wire is a temporary connection to earth because currently my gear inhibitor switch doesn't work, and in order to make the car function I need that at the moment. And then finally this one here, which is 87, is the wire that now leads all the way back across under the dash and connects up down to the starter solenoid. That's the white and red wire, which is the correct colour for that, and that just sits in the bottom there. The problem I have is that because everything was cut off from the starter solenoid, I don't have a temporary 12 volt connection going to the coil. They had put in a permanent 12 volt connection and that fried the coil. So I've replaced the coil, and at the moment I have a temporary 8 volt or 9 volt connection from the ballast resistor, the one that was provided with that coil. I tried connecting into both at different times this white and red wire and this yellow and white wire, on the basis that when you go over to start on the ignition switch, there's a temporary 12 volts going either to this yellow wire, and then I thought perhaps via the correct connections to the coil. If I connected into that white and yellow wire, because it was also connected to the ballast resistor, which comes on immediately you're in run mode on the ignition switch, the starter motor turned over immediately. The 8 volts that made its way back to the starter solenoid was enough to kick the starter solenoid in and start the starter motor. So I tried connecting into the out from the starter solenoid, the white and red wire, on the basis that that would only operate when the relay had already kicked in. Except of course that is permanently connected to the starter solenoid on my starter motor, and all that happened there was the starter solenoid had a hissy fit and would just buzz. So the only conclusion I'm coming to is the only way for me to provide 12 volts temporarily to that coil is to put in another relay. But at the moment it functions fine, but of course it's not cold weather, and this car starts really well. Because the starter solenoid is taking up to 6 amps, I've decided to modify the arrangements on the relay so that it's not drawing that 6 amps without a fuse straight from the ignition switch. I've moved the white and yellow wire from 30 and I've moved that over to 86. So 86 is just part of the switching mechanism. 85 and 86, these two here. So that'll only draw 2 amps maximum from the ignition switch. I've then connected the power in, which would be 30 here. I've now connected that to a new 15 amp circuit breaker. The wires are these thin walled wires, so there's more space inside the fuse box here. One thing I'll mention, and I've never done it before, is on something called Uncle Ben's Garage, and he deals with the American V8s mainly. Something he stated was that these crimped connections shouldn't be made without any other support. They should have some shrink wrap attached to them as well, because this gives them physical support at the junction. And he's probably right. What he's saying is that this junction quite often is subject to movement and can break. By putting a shrink tubing on, then that gives this junction here physical support and makes it much stronger. I've tried it, but unfortunately the one I've done it on is the one I'm now going to disconnect for this modification. That relay is now fused and only draws 1/2 amps maximum from the ignition switch.